Welcome back to the pre-calculus videos. This is lesson 3, describing graphs. This goes with section 2.1 out of our textbook. In this section, we are going to look about different ways to describe graphs. We're going to talk about where the graphs are increasing, decreasing, constant, positive, negative, or equal to 0, what the end behavior is, what the domain and the range of the graph is, and where any local minimums and maximums lie. Let's start by watching a video. This video was produced from Khan Academy. Now that we watched a video, let's look at the formal definitions as taken from the book. We have greater, the function is greater than 0. Again, we're looking for the intervals when the x values. What are the x values when the y values are positive? We're looking for the portions of the graph that are above the x-axis. If we go to greater than or equal to 0, now it's the same as the above description, but we're adding the zeros, the points that are on the x-axis. And we would look at changing from a parenthesis in our interval notation to a bracket. The function is less than 0. Again, now we're looking for what are the x values when the y values are negative. We're looking for the portion or portions of the graph that are below the x-axis. And again, when we add less than or equal to 0, we're doing the same as above, but this time we are including those points. Again, the big difference, we're going from parentheses to brackets as we include the zeros. So let's look at what he accomplished here for the positive and negative and add that to our formal definition that we've been using for intervals. So when we look at that first inequality, when f of x is positive, another way I can say that is f of x is greater than 0. That's the same as asking when f of x is positive. So when I put his statements into interval notation, I would be looking for the region where x is an element between a and b in union with c to infinity. Those are his statements moving from inequality notation to interval notation. If I want to talk about when f of x is negative, now again, I'm looking for when f of x is less than 0. We're describing it in terms of the x values, just like we did with our inequalities. So here, x is less than 0 when x is an element from negative infinity up to a in union with the region b to c. Again, we're using parentheses here because we are not including the x-intercepts or the zeros. The next thing he talked about in the video was the definition of increasing and decreasing. Anytime you see a yellow box like this, it represents a vocab statement taken from the textbook. It is very, very heavy on math symbols and math notation. So you want to make sure that this makes sense. As he described in the video, the function is increasing when x gets bigger, if y gets bigger. So I always think about when the function is, when f of x, the function, is increasing, I'm looking for x getting bigger and y getting bigger at the same time. So as I move from left to right on my graph, those y values are going up. In the second statement, what it's saying with all of that vocab is that if x, the function, is decreasing, what I'm looking for that interval, again, x is going up because I'm reading the graph from left to right, but this time my y values are getting smaller. He described a positive slope for the tangent line and a negative slope for the tangent line. The one that was not shown in our previous video is when f of x is consistent. So we want to think about this like a horizontal line. So as x gets bigger, again, I'm reading the graph from left to right. This time my y value stays the same. So we can deconstruct all of that terminology to represent it with simple arrows, and again, how it makes sense on a graph to give us more direction. So let's again notice that how we would write this using our formal notation. This time again, we're talking about f of x increasing and decreasing. So I'm going to write this f of x, and I am going to use that arrow, f of x increasing. He said it was increasing from negative infinity up to that turning point of D, and then again at the turning point of E all the way up to positive infinity. Then he said f of x is decreasing. Again, that was the purple notation. F of x is decreasing when x is an element between D and E. We want to use the vertices here, not the x-intercepts. Those vertices, or local minimums and maximums, as we'll describe later, are those turning points, the places where it switches from increasing to decreasing. Okay. So what I would like is for you guys to look at this example on your own, use the vocab, rewatch the video if you need to. All solutions will be in interval notation. We're going to come back together on our next class period and start by going over these answers. Again, you're going to look at when the function is greater than or equal to 0, where the function is less than 0, when is this function increasing, and when is the function decreasing. Please pay attention to where those points are that were clearly labeled for you, and make an assumption about points that are not labeled. If you need to, again, rewatch that video, make sure you understand, and we'll come back together to go over the solutions here. We're also going to look at some of those other questions that we saw on the screen at the beginning in Lesson 4. So we'll continue in Lesson 4 going over Section 2.1.